All right, this is section 11.5, which is inscribed, angled, and polygons. I'm going to start by doing 4 warm-up problems from section 1.1 to 1.4. So find the value of x. Since arc EF is congruent to arc GH, we know that these two chords are congruent, so x equals 9 here. Here, this is from the last section as well. Since this is a 90-degree angle, we know that this chord is bisected. So if this half is 7, then this half is also 7. And they want to know what's the length of WY. That would be 7 plus 7. So WY equals 14. Find the value of x. Now, since this is a 90-degree angle, that means this arc is congruent to this arc. So 5x equals 55 degrees. Divide both sides by 5, and x equals 11. And then find the length of GD. So because this is a 90-degree angle, that means this chord is bisected. So if this half is 10, then the other half is also 10, which means that GD equals 10. All right, definitions. What is an inscribed angle? Think of inscribed as inside. It's an angle whose vertex, if you look at the picture, here's the vertex, is a point on a circle. That's key. It has to be on the circle. And whose sides are chords of the circle. Remember, a chord has endpoints on the circle. So the two red parts you see here, those are chords. So here's the inscribed angle right here. What is the intercepted arc? That's the blue part in this picture. Okay. And there's a relationship between these two. What is an inscribed polygon? It's a polygon whose vertices are points on the circle. So if you look, if you see the red triangle here, it's an inscribed triangle because its points are on the circle. Okay, think of inscribed as inside. We also see an inscribed quadrilateral here because it has 4 sides, but all of its points are on the circle. So that's an inscribed quadrilateral. So then what's a circumscribed circle? It's this green circle here. And by definition, it's a circle that contains an inscribed polygon. So we call this a circumscribed circle because it has an inscribed polygon on the inside. All right, going back to inscribed angles and intercepted arcs, I'm going to show you what the relationship between those two are. If an angle is inscribed in a circle, so for example here, then its measure is half the measure of its intercepted arc. So here's the intercepted arc because here's the two chords, right? So this measure is half this measure. You can always remember like this is bigger, so this is double. This one's smaller, so it's half. So the measure of angle ADB, see how it's an angle, it's an inscribed angle, is half the measure of arc AB. So let's say arc AB was 20, then the measure of this angle would be 10. So for example, arc NP is 100 degrees, and we want to find the measure of the inscribed angle, which is right here. Well, it's going to be half the intercepted arc. The intercepted arc is 100 degrees, so the inscribed angle is 50 degrees. Same thing, this intercepted arc is 160 degrees, so half of that is 80 degrees, which is the measure of the inscribed angle. So if we were to write this out, we would say the measure of angle DEF is 80 degrees. Now they give us the measure of the inscribed angle. Okay, so instead of going from the arc to the inscribed angle inside, now we are given the inside inscribed angle and we need to find the intercepted arc. Well, we're going to double it. So 105 plus 105 is 210 degrees. So we're going from the inside to the outside, so we got to double it. Same thing, now we have the measure of the inscribed angle, and we want to find the measure of the intercepted arc, so we have to double. That's 240 degrees. If I were to write that out, I'd say that the measure of arc, KNP, is 240 degrees. Why would I say KNP? Because remember, this is a major arc, so we have to use 3 letters to describe this arc, MNP, since it's major. All right, next theorem. If this should say inscribed triangle. If an inscribed triangle in a circle is a right triangle, so here you can see the 90 degree angle, then its hypotenuse is a diameter of the circle. So if this is 90 degrees, then this is a diameter. So for example, you see diameter AB here because it goes through the center of the circle. Therefore, that means that the measure of angle C here has to be 90 degrees. So x equals 90 degrees because this is a diameter. Now, how do I find the measure of angle y? Well, if you remember, all 3 angles in a triangle add up to 180 degrees. So that's 140 plus x equals 180. Subtract 140 from both sides, and we get x equals 40. Oh, not x, sorry, y. We already know x is 90. We're trying to find y. There we go. Y equals 40 degrees. Just make that really clear. There we go. So y is 40 degrees because these 3 add up to 180. Again, this is the diameter of your circle, so I know that x is 90 degrees because it's across from my diameter. And then we know that all 3 of these angles add up to 180 degrees. So 125 plus y equals 180. So y equals 55 degrees. Again, these 3 angles add up to 180 degrees. And last but not least, we have a diameter here, which means that y is 90 degrees. Ooh, we don't know either of the x's, but they're both x, which means that these angles are the same degree. So again, let's add them all together. And we know that they equal 180 degrees. Well, what is x plus x? That's 2x plus 90 equals 180. Let's subtract 90 from both sides. And we get 2x equals 90. Divide 90 by 2, and we get x equals 45. So both of these angle measures are 45 degrees. So y is 90 and x equals 45. So in chapter 10, we learned about 45, 45, 90 triangles, and this is one of them. Last theorem. If a quadrilateral can be inscribed in a circle, remember inscribed means inside, so here's the inscribed quadrilateral, then its opposite angles are supplementary. So D and F would add up to 180, E and G would add up to 180. And it's only if it's inscribed. So if the 4 points of the quadrilateral are endpoints on the circle. So find the values of y and z. So opposite angles add up to 180. So 180 minus 80 means that z equals 100 degrees. And then 120 and y have to add up to 180. So 180 minus 120 means that y has to equal 60 degrees. Again, if the quadrilateral is inscribed and all 4 points are on the circle, then opposite angles are supplementary, meaning they add up to 180 degrees. And there's on your notes, it says note, supplementary means add up to 180 degrees. So 2 more examples. Opposite angles add up to 180. So x plus 95 equals 180. So I'm just going to do 180 minus 95, and that gives me x equals 85 degrees. And then y and 100 add up to 180. So 180 minus 100 is 80 degrees. So y equals 80 degrees. Again, an inscribed quadrilateral, so we know opposite angles add up to 180. So 180 minus 50 means that x is 130 degrees. And then we have y and 80. So 180 minus 80 is 100 degrees. And that's what y equals. And that's it. So let me look at your homework with you. All right, so this is what your homework looks like. I'm going to go through a couple examples in each section with you. Find the measure of the inscribed angle. Remember, that's half the measure of this intercepted arc. So we want to do 110 divided by 2, and that's 55 degrees. Okay. So you're just going to take the measure of the intercepted arc and divide by 2. So 218 divided by 2 means that this inscribed angle is 109 degrees. Okay, you do that for the rest of that section. Next, find the measure of the blue intercepted arc. So they give us the inscribed angle here, so we need to multiply that by 2 to get 64 degrees. So the measure of arc CB equals 64 degrees. So number 8, again, we have to double this, and we get 156 degrees. And that's the measure of arc BC. So that's all you do for that section. Find the value of each variable, explain your reasoning. This is where you look at your diameter, and across from your diameter, you always have a 90-degree angle. So x equals 90 degrees, and then we know that these three angles, 30 plus 90 plus y, add up to 180 degrees. So that's 120 plus y equals 180. Subtract 120 from both sides, and we get y equals 60 degrees. And you'll do that for number 21 and 22 as well. I know the numbers don't go in order. That's because I took problems off of your homework and I'm not going to renumber it. So number 23, these are like the last 3 examples on the notes. We know that opposite angles add up to 180. So 180 minus 114 is 66 degrees for x. And then we have opposite angles y and 92. So 180 minus 92 degrees means that y equals 88 degrees. And that's what you're going to do for 24 and 25. And that's it for the 11.5 homework. As always, let me know if you have any questions.